Hello and welcome uh, to a tutorial on how to use your computer to plot functions and graphs. Usually, when I was at school, and I'm still at school, I have one of these in my pockets, and these are what we call Texas Instruments graphing calculators, or there are other calculators such as manufactured by other companies. Uh, the one over here is I think it's HP maybe. Yeah, that's HP. And going a bit below, you have Casio. And what I love about the calculators is, especially these graphing calculators, is that they allow you to plot out functions to see what a function is on the screen, as opposed to just look at a function as its sort of variables. But there is a problem, and oftentimes, I found myself really frustrated by this thing that if you have, say, two, three sort of graphs that you would like to plot on your graphing calculator, then then they all become so mushy and become really sort of all together, and you can't tell apart one from the other, and that becomes a really pain. That becomes really painful to sort of understand what's going on. And recently I found that there are a lot of computer softwares that you can use to do the same thing that you do on these expensive graphing calculators much faster, with many more colors, and you can change the size, you can zoom in, zoom out really quickly, do a lot of other interesting stuff, which I'll cover in this tutorial, and sort of the upcoming tutorials. This graph that I have on my left, maybe let me zoom out. It's a bit too big. 50%. That looks right. So this is like a parabola that I plotted out in a program called Mathematica. And the really cool thing is I just had told the program, okay, look at this function and give me a graph, and this happens to be the graph. And the really cool thing is I mean, this is a really zoomed in graph, so it's plotted only between -10 and 10, and you can see the y values over here. I can zoom out further if I had wanted to, which I couldn't have done with sort of the graphing calculators, which I've used so far, and I still use, but I love the computer software because it's so much fast and so much easy to do a lot of graphing. I found so I googled what software to use, and I found like leading in the market in the industry, in schools and in sort of businesses and research places. They use Wolfram Mathematica. That's one sort of program for graphing, for doing any sort of computational work on the computer. The other one happened to be MATLAB. Sorry, my MapleSoft is over here. And Maple is quite close to my heart because, I mean, I live in Canada, so, and Maple is a Canadian company, so I guess I'm a bit biased towards their software. But I love Mathematica. I love MATLAB. I love the open source Python based program that does the same thing as MapleSoft, the same thing as MATLAB, the same thing as Wolfram Mathematica. But honestly, I found Mathematica to be a bit easier to use compared to the other three. So maybe that's why I began with Mathematica. And I wanted these tutorials to be on Mathematica, and maybe in the near future I'll cover MATLAB, and I'll cover Maple, and I'll cover Sage, because all of them are the same thing and just use different notations. But the functions, the graphs, the way you sort of get your work done is the same. It's like, well, if you know Microsoft Word, and then you switch to the Mac Pages, the sort of it's just a different interface, maybe a bit of different buttons and icons, but they get the same thing done. This is the graph that I had done, and maybe I should open up Mathematica and show it to you. How did I do it? So let me, by the way, just to go off at a tangent, if you didn't see, I'm using Photoshop to sort of make this tutorial, and I just put all these pictures here. So if you're curious in how I'm sort of making this video on my Mac, it's just Photoshop and put these pictures on. I'm using a different layer for writing stuff, and that's pretty much it. And the screen recording software that I'm using is has come with the Mac OS, I think, Mac OS 10 Lion, and it's just the QuickTime screen recording feature that I'm using to sort of record my screen. So no external software. Okay, I digress, but Mathematica, where are you? Okay, over here. So I opened up Mathematica now, and let me pretty much plot the function I had, plot the graph that I showed you over here. And Mathematica takes inputs, and inputs are basically sort of instructions you tell the program. So the first sort of instruction is plot, and plot takes arguments inside these square brackets. An argument is something that, I mean, by definition, it's a term. Argument means argument is something that's passed on to an instruction. So to the plot instruction, it takes a couple of arguments. The first argument is, well, what am I graphing? The graph over here was, a parabola graph in its perfect square form. So let me just type that in. It was 0.5 x plus 2 close bracket to the power squared. Let me make sure my brackets are the same because I oftentimes mess them up. So open bracket 1, open bracket 2, close bracket 3, close bracket 2, close bracket 1. Okay, good. So this sort of a entire thing is being squared. Okay, fair enough, fair enough. Close another bracket. Oh, and if you sort of remember, if you covered this already at school, I purposefully, made it in, express this parabola in its perfect square form. And it allows me to sort of see, well, oh, this graph is moved 2 units to the left. Oh, by the way, maybe we'll talk about that later. I think I'm confusing you by talking too much before actually drawing the thing. Okay. 0, 0. That just looks right. Okay, 2 multiplied by this thing, 0.5 x plus 2 to the power 2 plus 100. Let me check if that's right. Let me check if that's right. 2, 0.5, the entire thing squared plus 100. Yeah, that just looks right. Okay. So that's a parabola. Good. So that's the first argument. They gave plot. The second argument is, well, what values will x take? What values will x take, the variable? That's what I get to define here. I put this squiggly bracket, then I have x, comma. Let's see. Well, this one was graphed between -10 and 10. So I'm just going to do the same thing over here. -10 and 10. Close squiggly bracket. And that's it. So plot 2 arguments, and oh, by the way, now if I press enter, pretty much, the cursor jumped from this line to this line. So in Mathematica, it's shift enter Shift Enter to sort of tell Mathematica, well, this is the instruction I wrote. Now it's your turn to do the instruction. So I will now do that. Shift Enter, and oh, there's a graph. Okay. And oh, by the way, it tells us it's INs for input 115, and that's because I had before I sort of started this tutorial, I was messing around with Mathematica, so I did a couple of graphs to sort of refresh my own memory. So 115 means I might have done 115 types of instruction inputs before I did this thing over here, and output is okay. So instruction, and that was executed to give me this output 115. Okay. And to make this graph a bit larger, I can just hover over it, click, and this gives me the square with sort of anchor points that I can drag. The really cool thing is Mathematica holds the aspect ratio or the proportions of the graph, so I can click the side, pull it sideways, and still the graph is maintaining its proportionality. Make it a bit larger. Okay, so you may have noticed a couple of things. Well, it's the same graph as the one we saw over here, right? If you take a close look at it, maybe I'll pause here. But wait, this is like I mean this graph is 100. I mean this is a parabola which is 100 units shifted to the up. But over here that doesn't look like it has been shifted 100 units to the up. But this point here is 100. But I want that to be 0. And well, a couple of other things too. The background is pink. Over here the background is white. And I kind of see this graph to be much more stretched out, right? Sideways, like it got a horizontal. I think what should it be? It's horizontal stretch or compression, 0.5. So it's a horizontal compression by a factor of horizontal stretch by a factor of 2. This doesn't look like as if it was stretched horizontally by a factor of 2. Why is that the case? Because I actually, when I made the graph you saw over here, I had also put other commands inside the plot function, other arguments, which I didn't here. So the next video, I will do those and essentially show you how this graph became this, and also do some other graphs besides parabola. Maybe do some trigonometry graphs, polynomial graphs, irrational function graphs, rational function graphs, and do some cool stuff like compare one with the other, and just get a feel for how to do any type of graphs on Mathematica. So see you in the next video.